This is the second video about translations in transformation geometry. This one will focus on angles and sides, what is an isometry, what is a rigid motion, and perimeter and area. But first, let's start off where we left off. And that is, what is another word or phrase, or what a translation does? Do you remember that? And of course, the answer is, well, not sliding board, but slide. Let's investigate angles and sides of translated figures. All right, so let's go over to the tools and click on tools. And we want the templates and number 1. So it's tools, 1 templates, 1 angles and sides. This sets up the software, and notice that it measures all 3 angles of the triangle to the nearest hundredth. So we're going to go ahead and go, let's say, translate up 2 units and to the right 1, 2, 3, 4 units, and translate. And notice it's giving us the measures of angles A prime, B prime, and C prime as well. And what do you notice? Again, we'd like to investigate several triangles, so we'll grab, let's say, point A, look at the angles, grab point B, grab and pull angle C, and maybe even grab the whole triangle. And hopefully you're coming up with some kind of conjecture. Let's reset. And this time I'm going to add to the angle. Instead of the angles, I'm clicking on the eye, which is the drop-down menu. And let's go ahead and add connected segments to this one. Click on Done. And this time we'll go down 4 units. And we'll go to the left 1, 2, 3, 4, 5 units. And translate along those directions. And you'll notice now not only are we getting the angles, but we're also getting the connected segments like we did before. The black dotted segments kind of give you an impression it's 3D, 3-dimensional, but it isn't. And go ahead and play, investigate, explore, discover, keep looking at the angles and what you're noticing. You'll notice we also have a next here, so I'm going to go ahead and click on next. And if you're doing this with me, I invite you to do so as well. And it's giving us the lengths of the sides of the blue triangle and the sides of the red triangle, and I'm sure you can see the relationship there. But again, we'd like to investigate more triangles than just those 2. And it seems no matter how I pull it, well, that's your conjecture. I think what I'll do is go back to the drop-down menu, and I like to put in that resultant vector. I just think that is just a cool way to look at the math. And if I grab point W now, which I couldn't do it before, and put it on, let's say, point A, wow, same length, same direction, B to B prime, and C to C prime. And even as long as I go along here, some of the points that are along the blue you can see correspond as well. It's not just the vertices that are pushed or slid or slided in that direction, but all the points are. Press pause as needed. So returning to the PDF, look at number 4A. I think this is still on page 1 at the bottom. It says, if a triangle is translated, what appears to be true about the angles of the pre-image and image triangle, and please word your answer properly. You might have gotten caught when we did this with reflection, so be careful. Press pause and then play when you're ready to continue. So what we noticed was that corresponding angles of the pre-image and image triangles have the same measure, but make sure you're using that word corresponding. Do not allow students to say that all the angles are equal, because they are not. The ones that correspond, A to A prime, B to B prime, C to C prime. Press pause as needed. So turn over to the top of page 2. There's a wealth of information there on the top of page 2. You can see some things in bold, like isometry, rigid motion, distance preserving, angle preserving. So an isometry is a word that's used in geometry, and it's a transformation that does not change a figure's shape or its size. And you can see that this translation does not change a figure's shape or size. So a translation is an isometry. So a translation produces a congruent figure, congruent figures rather. A translation is an isometry. A translation is also called a rigid motion because it moves an object but preserves its shape and its size, which means they're congruent. And again, this is a rigid motion. It produces the same shape, same size. And finally, as far as terminology goes, we can also say that a translation is a distance preserving and an angle preserving transformation. Preserving, it preserves the distance, preserves the angles. Same angles, measurements, same side measurements. Corresponding, that is. All right, let's look at perimeters and areas of translated figures. So go over to Tools, click on Tools, Templates, and this time we're going to go to the second template, Perimeter and Area. So Tools, Templates, and 2, Perimeter and Area. And again, we can translate however you want, to the right 3, up 2, and translate. And you'll notice about the perimeters. But again, let's play, investigate, explore, discover. And I think you're already ready for some kind of conjecture. But while we're at it, let's click on Next and see the corresponding areas. So what conjecture can you make? So 6a, about a third of the way down on page 2, says if a triangle is translated, what appears to be true about the perimeters of the pre-image and image triangle? So press pause and then play when you're ready to resume. And not surprisingly, the perimeters of the pre-image triangle and the image triangle are equal. So this concludes Translations Video 2. Please continue on to Translations Video 3.